Hi everyone. We're going to continue our lecture. In fact, starting from today, we're going to talk the third and final part of our probability and engineering economy class. We're going to focus on engineering economy. And in this section, we're going to see more about use what we learned theoretically about statistics and probability to solve engineering problems and questions. So we have a more applied flavor in the third part of this project of this class. um, and there are a few things for today. There are a few things we're going to talk about in the today's class. Basically, the introduction to engineering economy, the general principles for engineering economy. We're going to especially focus on cost and then talk about break-even point when we are trying to understand the costs. Um, So let's get started. We're going to start with the engineering introduction to the engineering economy. And basically, engineering economy is a systematic evaluation of the economic merits of proposed solutions to engineering problems. Right. This could be you want to build a new building. What will be the engineering solutions? Right. You need to develop a new road. What will be the engineering solutions? And a lot of times they are not just going to be one engineering solutions, right? It could be multiple solutions. Do we build, you know, for Boston, right? We suffer from the traffic jam, a lot of traffic every day, especially during commuting time. And what will be our solution? Do we make our roads wider, longer? Do we have another big dig in Boston? Or we solve alternative ways to encourage more carpools or public transportations? Those are both have pros and cons, right? And some solutions may satisfy the need for certain population rather than the others. And so in this cases, how do we evaluate the merits of these solutions and find the best one? And when doing so, a lot of times we need to balance the trade-offs of alternative designs. Um, uh, in the end, really, we most likely are trying to find the economically acceptable solutions. We say economically acceptable solutions. Um, we didn't use optimic solutions because a lot of times optimization is a hard thing to define, right? Um, what do you mean? What can a lot of things can mean optimal, and it's really hard to say which one is optimal against the other. A lot of times we find acceptable or satisfactory solutions, and of course for these solutions, especially in current situations, we're trying to make sure that they can generate positive long-term benefits. Right? So that's the core part of the engineering solution, engineering economy. Um, Two books, if you are interested, could be really related to what we are going to talk about. One is Contemporary Engineering Economics, written by Chan Park. Uh, Really interesting book. Talk about solving a lot of um, modern issues we're facing in engineering economics. And then there's also the engineering economy. In my view, it's a more classic one, but touch on a lot of very great principles. So engineering economies, here's one example. We kind of already solved some problems kind of related to this, kind of like this before in class, but this is very typical or a good example of what is engineering economics, right? So in this case, what we are trying to solve is that for one auto corporation offers two types of financing options for a car priced at $14,695, right? It can be traditional financing or lease financing, right? For the lease option, the lessee must come up with 731.45 at signing. So when you sign the lease, you need to have that money. Uh, this cash is due at signing, including the first month's lease payment and $495 for administrative fee. No security deposit is required. However, a 300 disposition fee is due at lease end. Right? So at the end, you also need to pay another fee, which is $300. The lessee has the option to purchase the vehicle at lease end for $8,673.1. Right. Assume that this is also the value of the car at the end of 36 months if it is bought and the owner decides to sell it. Right. So basically means that assume that after you lease the car for 36 months, that you can actually sell the car for this much money, right? For the buy option, the buyer must secure a loan at an annual rate equals to 3.6%. So each year your interest will be 3.6%. So in this case, which financing option is a better choice? This financing option is a better choice. It could have, you could have facing this decision or this financial option very soon if you haven't already facing this, right? Should I lease a car, which I don't need to pay? Sounds like it's very good deal. I don't need to pay that much. At the end, I still have the power to buy it, option to buy it. And if I do want to sell it, I'm always driving a new car, right? It could also be, but compared to the more traditional one, right? I secure a loan. I just use that to buy the car and then pay a monthly payment. What would be the result, right? So which one is better? This is this is actually the way to compare it, right? If you put all the options together, you can do a very good comparison. So the price of the vehicle is the same, no matter you are using the first option or the second option, right? Down payment, you only need to do that for traditional financing, right? So theoretically, you don't need to pay any other thing, right? For option two. For option one, you do have interest, annual interest, which is 3.6%. And for leasing financing, lease financing, you don't really have that. Monthly payment, it's a bit higher, right? Each month you need to pay 372.55 $2.55 every month. That's for the traditional financing. But for leasing, you only need to pay $236.45, $236.45, right? Length is the same, right? Either way, you're going to have it for 36 months. And then the fees is $0 for option one, but you need to pay close to 500 second one, right? You need to pay a cash due at the lease end. For option two, there's nothing for option one, right? For option 2, you need to pay $300. And at the end of this 3 years, well, for option 1, the car is yours, so you are not paying anything, right? This car belongs to you. But for option 2, you need to pay $673.10 to buy the car if you want. And if you buy the car, then assume that you can turn around and sell it to your friend. That will be the same money, right? So because you have a down payment, one cash due at signing will be $2,000. But for leasing, you need to pay the $236.45 plus the $495 at the beginning of the lease, right? Oh, that's the difference. And of course, this APR is the interest on the loan, right? This is interest on the loan. And that's meaning that, meaning although at the beginning the price will be $14,695, but at the end, the cash flow you're actually giving back, giving to the bank, you're paying for this will be higher, will be more than this value, right? And how much higher, that is determined by the interest, obviously. So how do you calculate this, right? How do you calculate this? What will be the solution? You can pause and think a little about it. Feel free to calculate here, but I'm actually not going to discuss this in this video. Tomorrow during our online session, I'm going to do a Q&A on this question. And I'm also going to include this solution in our notebook. But I mean, this example actually demonstrates, right, what show you what is a successful project. What is a successful project? Now here, I do want you to think a little bit. You see the dog, the video, right? The surprise dog. And think about it. What is your, what could be a successful project, right? When you think about it, in your mind, what is a successful project? Okay, so there are many things defined as a successful project. First, it is built with engineering feasibility and financial feasibility, right? Engineering feasibility, meaning that your solution is valid. The building will not collapse. The bridge will not collapse, right? You have the, if you build another big dig, that's going to be able to solve the traffic jam or long commuting time in Greater Boston area, right? That will be the engineering feasibility. Then there's also the financial feasibility, right? Do you have money to build the big dig? That costs a lot of money, both federally, both federal money and the money from Massachusetts state, right? Do we have that money to build that? Also, it means, same thing, right? If you want to build a building, we all know that Northeastern expanding. We have more students, we have more faculty, and we need more lab space. If we can build another 100 tall building full of labs with all kinds of cutting edge equipment, that would solve all of our problem. I would love that, right? But a lot of times it's not feasible, right? We don't have that kind of financial feasibility to build whatever we want. Then within our budget, what is our best solution, right? So here's one example, and you can see in the figure, well, a car dropped in the water, right? So they get a small truck to pick up the car. So it works at the beginning, and it doesn't, right? The red car trying to save the white car, but then it's failed. So it doesn't have the engineering feasibility to finish the project, right? So then we do need to get a bigger one, right? See if we get the green one, problem solved. We pull up the white car, no issue. So our problem solved until we need to pick up the red truck from the water. And we failed again on the engineering feasibility direction domain, right? So that's what I mean by engineering feasibility, right? So for a successful project, we want engineering feasibility, we want financial feasibility. Then we want the benefits of the project are indeed greater than the cost, right? Often, a lot of times we have option A and then we have option B, right? So which one is better? For one to win, like I show in this figure, you know, one need to really have a benefit, clear benefits over the other, right? Indeed have greater benefits than the other. The project, another attribute, characteristic is the project was built in an efficient and effective manner, right? Like what these two workers are doing. Very efficient, very effective, right? So we can achieve what we want to do in a very efficient and effective manner. And then for a successful project, we also want to make sure that there's no clearly better options than the one we already selected, right? We compare multiple solutions here, and then we find, okay, one is pretty good, and we're comfortable with it. But we also know that there are no alternative solutions. We didn't omit other pretty clear better solutions. We're humans, right? So there's a limit on our capability, and sometimes, you know, for a certain time period or limited by technology or maybe our imagination or knowledge, we have tried very hard, we get the best experts, we think this is the best solution, but we might miss one. And maybe later it turns out, okay, there is a better option. We couldn't foresee, be able to foresee that before, right? But that could be the case. That could be the case. But either way, this option shouldn't be very clear, shouldn't be very obvious at the beginning, and we shouldn't omit it, right? That's what I mean by no clearly better options. Then, for another one, no significant externalities, like what I'm showing here, right? Working on something for sure, but make sure that there's no, it's not going to cause problems. We want to foresee the risk and make sure that our engineer solution not going to cause more harm than that we cannot foresee, right? That's also something we want to do very carefully. Also, building this project did not foreclose other, even better projects. Not foreclose even other projects. We don't want to build a giant hotel or some significant infrastructure to show our ego, but fail to bring some and achieve some better projects, right? That's our that should be our goal to achieve a successful project. Right? So of course there are other principles when we're really trying to make decisions with our team, with our collaborators. with different parties and stakeholders, we need to think this through. But these are the general ideas, right? What is a successful project? And of course, to make sure that it is success, we want to have evaluations, right? Before and after, certainly after the project as well, right? The evaluation processes. Evaluation really is about different organizations, no matter it's public or private, how do they make decisions on how best to pursue their objectives? How best to pursue their objectives? This could be uh, we need to answer the questions. What are the projectives? How are we? What are the objectives? How can we achieve these objectives? And at what timeline? At what time should we try to pursue these objectives, right? And of course, organizations use different evaluation techniques which focus on alternatives and search for the option that really maximize the payoff, really try to maximize the payoff. The main difference between private and public sector organizations, although, lies not so much in the evaluation principles, but rather in the frame of reference. Rather in the frame of reference. So the evaluation principles are usually the same, but the difference for private and public sectors when they try to achieve certain objectives, the real difference is in the frame of references. So what are these? The frame of reference, really what it is. Um, for private sector, usually it's the firm itself, right? The frame of reference for a commercial entity is really the firm itself. The payoff is internal to the firm, right? Usually it's internal to the firm. And it comes in the form of the return on investment. So a firm's evaluation of project would focus on the impact of that project on its financial accounts, even though the options under consideration would often have effects extending beyond those accounts, right? What does that mean? That basically means for a private entity or commercial entity, really the ultimate goal for evaluation is trying to make the firm perform better on financial accounts. But of course, a lot of times, if you only consider financial accounts, it cannot achieve the best result, right? So a lot of times, if the company just trying to make the most profit, but generate a lot of pollute in the nearby neighborhood, or pollute the water and cause health issues for the people living nearby, then that could that's harmful, right? That's unethical. But to the end, and then ultimately it will cost the company own credibility and even the company itself, right? So in the long run, it's going to hurt the financial accounts. So companies usually do a lot of things. They do the right things to align with their financial interests, and at the end they can make money, right? One example would be the plant location, right? The plant location. So of course it's a financial pursuit in the end, right? They want to make money to build the plant to produce products and to make profit. But on the other hand, many of the issues, from environmental perspective, from a social perspective, from other legal perspective, will play, right? So need to based on all these factors to make the best decision and still maximize the financial income, right? Or the return on investment. Well, that's for private sector. For the frame of reference for public sector is different. It's really the society at large. Society at large. While government agencies are concerned with the effect of project options on their own financial accounts, their interest really goes further. Their interest really goes further, right? Extending to the costs and benefits to be realized by the entire society. And one example would be a new road, right? If I build a new road, usually the government doesn't really get a lot of invest return from it, right? Usually don't get return from it, especially in the U.S. Um, and building the road is really serving the society, the general public, right? And then when people are making decisions, right? Okay, we want to build a new road for people to commute better, to drive shorter, to save gas. But we also want to make sure the new road doesn't, increase safety issues, doesn't cause problems for vulnerable populations. And maybe there's another consideration that where do we build the road, right? um, uh, uh, Maybe the more disadvantaged neighborhoods need a road, need a better infrastructure, right? Then it may not generate a lot of economic benefits, but the road need to be there to help them, right? And sometimes these can be intertwined, right? The private sector and the public sector need to come together to find solutions. Not sure if you ever heard about the PPP, which is public-private partnership, right? So basically, the private sector and public sector come together to work on something. Not sure if you can think of any example, but I guess the most typical one would be build road, right? The government allow the private sector to build a road and then charge tolls for a certain time, a certain period of time, maybe 30 years, 50 years, collect tolls and then pay back. And then after 30 years, the road belongs to the public sector, right? Another example can be how Boston and Massachusetts governments trying to, you know, uh, get GE to move their headquarters to Boston, right? When GE moved here, of course, they want to pursue their best interest, their best financial interest. The move will have the best return on investment. But and Boston government and Massachusetts government, of course, see this could be a good opportunity to generate, um, you know, good social impact in the Boston area, right? So they come up with a package which is basically paid by public tax, um, but can use that to attract GE to move their headquarters here, right? I think we did a similar thing to Amazon, but um, I guess we didn't really attract them to come here. But that's what I mean by sometimes the benefits can align. It could be a win-win situation, and although different sectors can have different goals in their mind, they can work together and to figure out ways to make certain objects be done, right? So that's the evaluation part. There are a few principles of engineering economy. These include develop alternatives, focus on differences, use a consistent viewpoint, use a common unit of measure, consider all relevant criteria, make uncertainty explicit, and revisit decisions, right? I'm just going to talk about them very briefly. First one, develop alternatives, right? The final decision or choice is among different alternatives, right? The alternatives need to be identified and then defined for subsequent analysis. A lot of times, let's say North System want to build a building. Remember when we tried to build the ISAC building? Um, yeah, we first approach different design firms and ask them to provide us preliminary design. And then based on these alternatives, we decide which one is the best, right? And use that to conduct subsequent analysis. And that's what we mean, right? So they all serve the good purpose, and our purpose, we just want to find the best one. And eventually we find one. We decided the ISAC building, what we build, the design is a serves our purpose the best. So we choose that, right? Focus on differences. Of course, when you have alternatives, there's many differences, right? Only the difference in expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decision, right? We understand what are the differences. We try to see how the differences going to bring different outcomes, and we're trying to decide which one we want, right? And which one is really the one we want. Use a consistent viewpoint. It means that the prospective outcomes of the alternatives, economic and other, should be consistently developed from a defined viewpoint perspective, right? Should be defined from a defined viewpoint. So for the different alternatives, let's say Northern wants the ISAC building to maximize lab space for different faculties. And then for each alternatives, we want to evaluate it similarly, right? We can't just for another alternative, we think, oh, looks very nice, so much nicer than the other one, and I'm going to keep this one. Forget about lab space. I'm just going to focus on the appearance of the project. That creates an inconsistent viewpoint, and that evaluation just does not serve the purpose. Right? Use a common unit of measure, and it basically means to enumerate as many of the prospective outcomes as possible. This will make it easier to analyze and compare the different alternatives, right? So basically, we're trying to develop rubrics and have a same way to measure them, and then we can aggregate together to make a decision, right? Consider all relevant criteria. The selection of a preferred alternative, which is basically the decision-making part, requires the use of a criteria or several criteria, right? The decision process should consider the outcomes enumerating the monetary unit and those expressed in some other unit of measurement are made explicit in a descriptive manner. Right? So usually it's pretty easy to count money, and that's going to be the focus of this class, of the third part of this class, right? But a lot of times we do use other units of measurement. Let's say how many labs we're going to be able to use the ISAC building example again, right? How many labs are we going to be able to house with this new building? That's a very important measure, right? Maybe it's hard to directly measure or add a monetary dollar on it, but it's really an important thing for the university, right? That's a constraint we want to solve. And it also could be how many or how much common space, public space we can provide for this design, right? We see there's a lot of common space in ISAC and people can sit there, students can enjoy themselves and work together. That's important, right? To maximize space, the common space could be very important, right? And it also could be I don't know, maybe energy consumption, right? Sure, we can put a monetary dollar on it, but on the other hand, we also want to, uh, you know, understand, how much energy we are saving. It has a value beyond just how much money we're going to save, right? Those are the relative criteria. Make uncertainty explicit. So like I said before, right? Sometimes when we use our best judgment, there's still uncertainty, and uncertainty is really inherent in estimating future outcomes of the alternatives, and should be recognized in their analysis and comparison. Right? We want to make sure what will be the uncertainty. One example is that I don't know if you know about the lead. Uh, the lead criteria basically is a way, um, a standard or the certification to build a green building in the U.S. Right? So many buildings, it's a very popular criteria or certificate. Many buildings trying to achieve a certain level of LEED to make sure that the building is certified as a green building. So that's really important, right? It's of course a good thing. And LEED, which spelled, sorry, I forgot to say LEED, which spelled as LEED, which is leadership in energy and environmental design. It's developed by the U.S. Green Building Council, and basically, they have criteria. If you achieve those criteria, you can achieve a certain level of LEED certificate. It's really good. I think the concept really works and gained its popularity. One challenge is that when we try to estimate how green the building is, we do energy simulation, right? However, a lot of times the simulated result are very different from the result when we really build it. And it turns out that sometimes we don't really achieve energy conservation with LEED certified green buildings. And in certain cases, it's even worse than just buildings built without any energy saving efforts built into it, right? Designed into it. And that's uncertainty. We tried our best, but because human behaviors or other type of things, it didn't achieve that. So we want to quantify that kind of uncertainty, right? This would be our expectation or the expected energy consumption after the building is built, but there are uncertainty built into it, and we want to make sure that uncertainty is explicit and recognized and understand and evaluate it before we make the decision, right? Sometimes if the uncertainty is too high, add a lot of risk, then that's going to impact our decision, right? Revisited decision, which really is improved decision-making result from an adaptive process. Meaning that to the extent possible, the initial projected outcomes of the selected alternative should be subsequently compared with actual results achieved. And that's really, what the green building, the LEED certificate is a good example, like we said, right? After you build it, you want to really see, based on your decision, what is the outcome? Have we achieved the outcome or not? So that's very important principle to achieve an engineering economy in engineering economy, right? So those are the principles, and the engineering economy and its design process is really accomplished using a structured procedure and mathematical modeling techniques. Right? The economic results are then used in a decision situation that involves two or more alternatives and normally includes other engineering knowledge and output. That's how we study it. We following all the principles, we study it and then achieve the engineering economy. So this is usually the process. For engineering economy, right? What we really want to we need to do what we need to do is problem recognition, formulation, and evaluation. We want to make sure we develop the feasible alternatives. We want to develop the cash flows when we based on different alternatives. We develop the selection of criteria. We select the best criteria. Do the analysis, compare of the alternatives, select the preferred alternative, and perform monitoring and post-evaluation results. Right, that's what we need to do for engineering economy. And then, in the to achieve that, or in the design process, really, it's on the right side, right? To achieve each, what we need to do, and you can read more about it. They are pretty similar, but have some differences here. Here's one example. To achieve the engineering economy, right? To help you to think about engineering economy. A construction company has to increase profitability to obtain a loan for equipment upgrading, right? That's one example. And that's the general scenario, right? But then in real world, a lot of times it could be something like this. A small construction company owns a truck that has been badly damaged, and the company needs a truck as soon as possible for their project. How should they proceed, right? Then in this case, should they try to buy one, or should they lease one and then to do the project? If they buy one, what will be the cost? What will be the benefit? What will be the risk, right? And for leasing, what will be that cost, right? Obviously, if you buy one, you own it. Leasing one is only temporary and to return later. Leasing usually result shorter loan, and a lot of times you put insurance on it, and that can help you to protect you from any risk, right? You buy that, all the repairs you need to pay for it, right? But so all the kind of decisions we want to make, right? What should the company do, right? So in this case, you can see that there are alternative options, and they really just relate to the cost. What would be the cost, right? And this when we try to do this, a lot of times we need to do the cost estimation or cost estimating. It's really what it is really to forecast the present and future cost consequences of engineering designs, provide information used in setting a selling price for quoting, bidding or evaluating contracts. Right? This could be for sale, for bid for project, or evaluating the feasibility or financial benefit of certain contracts. Right? determines whether a proposed project can be delivered at a profit. That's, you know, you need to that's going to determine your price, right? You have the price equals to the cost of the project and the profit you want to make from the project. Evaluate also cost estimates include the evaluate of the capital can be justified for process changes or other improvements, right? Also used to establish benchmarks for productivity improvement programs, right? That's cost estimating. Um, of course, it's it's easier said, but when we really do the deliver a project or doing cost estimating in real world, it's much more complex and difficult, right? Um, the general principle is similar, and let's say for the traditional design, right? When we're trying to do the design, we're trying to figure out the cost, and it could be something like this, right? It could be something like this. At different stage, it's programming, design, document development, construction document development, and then construction, real construction phase. And that's the effort we need to put into it. That's the effort we need to put into this, right? At the beginning, it might be lower, and then gradually increase, When in the construction documenting phase, it's at the high, at the peak point, and then slowly going down and going to the construction phase, right? So if this is our effort, um, this curve actually shows our ability to control the cost. Our ability to control cost. What does that mean? That means that if you make decision early, that can help a lot to control your cost. Let's say you are in the design phase. You'll find out that, okay, this beam, if you put this beam here, it's going to run into the pipe system, or the concrete really cannot be this type. We need to use a different type of concrete for our foundation, right? So if you, at the design phase, you figure out, well, you can easily change, relatively easy to change the design in your drawings or in your building information modeling model, right? So that cost will be lower. But if you're already in the construction phase, you already put the concrete, and then you start to building the upper structure, and now you realize, okay, there's actually a problem. Uh, the uh, the material we use in foundation, or the reinforcement we use in foundation is not strong enough. Now we need to tear up the foundation and start doing all over again. That's going to be very costly. That's going to be very costly. So this curve, that's what it means for this curve. At the beginning, if you identify any issues or you want to make any change to make the project serve your purpose a little bit better, then do that. And that's going to save you a lot of money. And that's why we need to pay a lot of attention at the beginning, right? So relate to that, like what we said, right? If we find something later, we find some design problem later, we want to make design change later, the cost is going to be much higher, continue increase. That's the end. Right? When we towards to the later phases of the project, right? And at this point, you can see that the two cross each other, right? Well, to avoid that we paying more, if we need to do a design change later in later phases, and we need to pay more money, then one thing we can do. Oh, one thing I forgot to say here is that this traditional project or design process also result a lot of litigation phase. If you have been working in the industry, you probably see this a lot, right? For my years, I'm from construction area. For my years seeing real cases, I never, literally, I never see one case have no litigation. I never see one project have no litigation. They always have certain litigation, right? Because of the design change, one people point finger at each other and saying this is not my fault. You need to pay for this, and then always result in litigation. So to make sure that, well, to help that we don't need to pay so much later stage, and we don't need to result conflict to get a conflict because of different interpretation on design. One practice is that we can move the effort up front. So basically move this part forward, right? This means that at the design phase or the programming phase, we put more effort into it. We try to have more people look at the project, look at the design to make sure they make sense, to make sure they satisfy our need, and to make sure that, okay, this can be solved, right? We don't have problems in our design, so we don't have the issue with concrete that cannot is not strong enough. We don't have the issue that pipes run into walls. We solve all those problems early on, so we can move the effort forward and then try to avoid all the cost, right? And also, if we can solve that problems early on, maybe we not going to result any problems. We don't need to worry about at the end we need to point fingers at each other, and maybe that can reduce our litigation cost, right? We don't need to go into the litigation at all, and everybody save money, right? That's more modern project delivery. I'm actually teaching a class on integrated project delivery. That's called and integrated project delivery, or IPD. You might already heard of it, and some other project delivery actually aim to do this, right? We have bring different team early on. We bring people together early on in an early stage of project. We make sure we do the best design and best you know value proposition or value engineering to make sure we have the best result. We get input from different stakeholders and different parties, the contractors, key subcontractors, end user, to make sure that the people are satisfied with the design. Then yeah, you do need to put more effort early on, but you can save a lot of money later on and result less design change. Right? That's a goal. So for cost estimating, right, there are really two approaches. One is top down, and the other is bottom up. The top down approach uses historical data from similar engineering projects. You use the project to estimate cost, revenue, and other parameters for this current project, and you modify original data for changes in inflation, activity level, weight, energy consumption, size, all the other aspects, and then you can kind of generate a relatively not accurate, but a ballpark of the project, right? So you get a sense of the cost of the project. This really is used in early stage. It's not so far from guesstimation. Not sure if you heard about that term. That's really not really far from guesstimation. A little better than that, and a lot of times you don't end up with one number. You end up with a range. Okay, based on all this, people built the Empire State Building in New York. I don't know, 90 years ago, I think. So now, okay, we're going to build a similar size of building in Boston. Boston is cheaper than New York, but because, of course, that's 90 years ago, the costs are different when you count inflation, and then, it's actually become really crowded. We need to do very good logistic control, um, all this site control, all the kind of things, right? So based on that, you can estimate, okay, I have that data, and based on that data, I estimate what I'm roughly this will going to be this much money in Boston, right? So that's top-down approach. Then the bottom-up approach is really a more detailed cost estimating method, right? We break down the project into small, manageable units and estimate cost, right? This could be, uh, per square uh, kilometer or per square feet, per square foot, what will be the cost? Then I can add them together. Or, for concrete, how much we're going to use, what will be the cost, plus the indirect cost and labor and overtime, all those kind of things put together. So uh, then this will be, for the HVAC system, what will be the cost for uh, glasses, what will be the cost? All this money we break down to different units, we do the estimation, and then we find the cost. We get an overall cost estimate, right? This is really works best when detail concerning designed output has already been defined and clarified. So in this case, we know that, okay, it's not like at the beginning, okay, I want something like uh, Empire State Building. No, I do want to. It's still something like that, but it need to be 150 floor tall, and it need to have all glass outside. You need to have certain kind of common space inside. The HVAC need to control the temperature to a certain degree. All those kind of things, the details has been defined and clarified, and then we can do a good estimation bottom up and make it more accurate. Right? So that's the true approach. Um, I think I'm going to stop here. That's already a lot of information. Um, Let me know if you have any questions regarding this lecture. Next time, we're going to talk more about cost estimation and also look at some examples. So talk to you next time.